All right, welcome back. So we're going to finish our discussion on sines and cosines, graphing them. And I think the best way to go just be pick up where we left off and have that go. So let's go ahead and share. And we'll just bring up the sky and the sky. And we'll go for this one. All right. So to find the amplitude, so it says write a function in the form a cosine bx for the given graph. Express your answers in terms of a simplified fraction. So we're going to have f of x is equal to a cosine bx. So we have to find the amplitude. Okay. So cosine, good. All right. If we look at the max and the min, right, our amplitude is going to be the max minus the min over 2. Now, on this graph, it's pretty easy to tell, right? It's 3 units above the baseline, 3 units below the baseline. Our amplitude is going to be 3. Okay, by inspection. Okay, because we know that it's, how cosine works, and the maximum, whatever the max is, right, that's going to be our thing. What if you didn't have a baseline? What if it was hard to tell? So we're going to say 3 is our maximum minus -3 divided by 2, 6 over 2, that's 3. Okay, so in both cases we got 3. We have a way to figure it out if things are not quite as clear, but we also have a way of figuring it out if it is clear. So our A is going to be 3. Okay, great. So oh, they just want the whole function. Okay. I was expecting the right amplitude, so we'll wait on that. Now, period is a little different. Okay, now you could think that 2 pi over b is equal to a period. And here, beginning of 0, ending of 6 pi, right? This is going to be 6 pi. Okay, so we have to solve for b here. I'm not exactly happy with this particular method because it requires you to know this formula, and I hate the fact that you guys would have to do that. So we have 2 pi over b is equal to 6 pi over 1, cross multiply, so we get 2 pi over 6 pi is equal to b over 1. B would be 1/3. Okay, that's one way to go. We also know that the vanilla cosine ends up stopping right at 2 pi. So it goes from 0 to 2 pi normally, right? So what do we do for that one? Okay, so we have a k with b, okay, and then we want 2 pi in here to be equal to I'm sorry, no, we don't. We want k times 6 pi to be our end. Okay, so what we're trying to do is saying cosine of 2 pi, I'm happy with that. Okay, that equals 1. How do I force the inside here, right? How do I force the inside here to be looking like 2 pi so I can get my answer that I want? Okay, so we're going to say that k times the end that I'm giving, right? I'm giving 6 pi, saying that's got to equal 2 pi. So something times 6 pi should be equal to 2 pi. Okay, so something that we have times the value in here is going to be 2 pi. So again, divide both sides by 6 pi, and we end up with k is equal to 1/3. Okay, so let's just reason that back. Okay, if I've got cosine of 1/3 x, okay, what I'd really like in here, right, is to be 2 pi. So I would really like 1/3 x to be 2 pi. Okay. And that's what I'd like to take my cosine of. 6 pi, there's a 1/3 here because of my b, and that is equal to. So this 6 pi is that is the actual end, but I'd really like to think about the n being 2 pi instead. So I want to equate these two things together, okay? So I'm going to take my k times whatever my n value is, 6 pi, and set it equal to my preferred n, 2 pi, okay? So this is what happens. This is what goes on in the center here, the middle, okay? So we're going to end up with f of x equals, what do we have here? We have 3 cosine of 1/3 pi, 1/3 x rather, okay? And then we'll write that down. So we have 3 cosine of 1/3 x. All right, and that's going to be our value there. Okay, we should probably do another one of those just for the sake of doing it. Okay, which is the nicest thing about Connect Math, which is the nice thing about all of these, is like, I don't quite get it. Like, check again. Okay. So in this case, okay, we have a sine this time. Okay, so we have f of x equals a sine bx. Okay, so again, our amplitude, right, is going to be our max minus our min divided by 2. So our max is 3/2, right? Our min is -3/2 divided by 2. So we have 6/2 here, right? 3 minus -3 is 6, and divided by 2. Well, it's 6 over 2. That's 3. 3 divided by 2 is 3/2. Okay, and again, by inspection, you can kind of see 3/2. Now, sine, I would like sine to rise at the beginning. So I'd like sine to have this shape, but instead, okay, instead it has an opposite shape, right? Instead it has that shape. So there's got to be a negative in front of this, okay? It's got to be a negative. Myself on camera here. Okay. So our amplitude is still 3/2 because it's the absolute value. But the coefficient I want in front here, that's going to be -3/2. Okay, so that's our first business. All right, now, second business. Okay, so we have the sine of a kx, okay, that's on the inside here. And this length, right, this goes from 0 all the way out to 8 pi. Okay, now we could go off and say something like 2 pi over b is equal to, what's the period, is 8 pi, okay, cross multiply. Okay, so we have 2 pi over 8 pi is equal to b. B is equal to 1/4. That's one way to go. The other way to go is like, well, I'd like this whole business in here, right? So regardless of what this is, I'd like this to be 2 pi. And my x value is 8 pi. So we have k times 8 pi is equal to 2 pi. Or so, I guess I should just be in here, okay? But we're going to go ahead and divide both sides by 8 pi, divide both sides by 8 pi, and end up with a b is equal to 1/4. Okay. Because again, I would like to be able to take sine of 2 pi. That would be great. Okay. How do I make this inside stuff equal to 2 pi? How can I do this? Kx equal to 2 pi, knowing that x has to be, right, 8 pi. Okay, so that's what we're doing there. All right, so this is going to be, this equals what? What was our first value that we ended up with was negative 3/2 sine 1/4 x. I'm going to put this in parentheses because you don't want to have confusion there. Okay. All right. So that's the kind of thing we're looking at. Okay. All right. Do we have phase shifts next? No, we just have modeling. Okay. Okay. So the graph shows the percentage and decimal form of the moon illuminated for the first 55 days of a recent year. Okay. So where is this starting? Is it starting in the middle of the wave, or is it starting at one of the edges? I think it's starting at one of the edges. So when I'm trying to model this, okay, if they're giving me something that looks something like this, I'm going to want to go with a sine wave. Okay, even if they give me something like that, it starts at 0, I'm going to want to have a sine wave. If it starts somewhere other than 0, okay, it starts up here, or it starts down there, I'm going to want to go with cosine. Okay, so this looks like it's, to me, this looks like it's going to be a cosine. Okay. Oh, actually, let's go ahead and read the problem so we don't have to work harder than we do. Okay. On approximately which days during this time period did a full moon occur? Okay. Percentage of the moon illuminated. Okay. So when it's 100%, see there's a 1 here? When it's 100%, we're going to say that it's a full moon. Okay. So let's see here. Which days did the full moon correspond to 100% or 1? Okay, it occurred on, looks like day 10. Okay. And it occurred on day 40. That makes sense. So that looks about right. All right. On which day was there no illumination? Well, that would be the new moon. So that would be all the way down here at 0. Okay, so that would be day 25. Okay, you see, all the way down here at 0. No light from the moon, new moon. Okay. From the graph, approximate a periodic sinusoidal month. Okay, the approximate. Okay, a sin. Oh, that's not sinusoidal. It's synodic. Synodic. Okay, synodic. Okay, a synodic month is a period of one lunar cycle, full moon to full moon. How many days does this period go? Well, right, it goes from day 10 to day 40 is one wavelength, right? You just go top to top. Okay, we can try to find this one again. Say, well, where is it? From here to about here, right? But we're starting to get 30 days, right? So 40 minus 10 is 30. We're going to say this is approximately 30 days. Okay, I was expecting us to have to go through and model this thing. Glad we don't. Okay, but we want 30 days here. Okay, so check our answer. Hooray, we're good. Okay, they didn't ask us too much of a horrible question here, so that's good. All right. Indicate the phase shift and whether or not the phase shift is to the left or the right. Let's talk a little bit about phase shift before we start. So a phase shift is a horizontal shift. Okay, phase shift is a horizontal shift. Okay, so do you remember, like, if we had a positive, like, remember this was going to be like x minus 3 squared. What did this look like, right? It was a graph that was shifted over 1, 2, 3, okay, and that was our shift. In trig, we call this a phase shift. So this was a shift, you know, when it was minus 3, it was a shift to the right. Okay, if you remember what does x plus 5 square root look like? And that was 1, 2, 3, 4, 5 here, and then there's our shift. Okay. Now, if you have we didn't really ask this in college algebra, I mean, we used to, but I was told not to ask this anymore. If we had like make an easy one, okay? How about if we do like a 3x plus 3 square root, okay? Or a 3x plus 6 square root, okay? Where do I start? Like, what's the domain? And how do you figure that out? We can say this is 3x plus 6 equals 0, right? Because taking the square root of 0 is nice, but taking the square root of this thing, we have to figure out, like, well, where's the 0, right? If the square root of 0 is 0, why don't we start there? So we'd have to do something like 3x equals negative 6, x equals negative 2. Wait a minute. We said our phase shift, our horizontal shift should be 6. Where'd this negative 2 come from? Well, it came from here. So we have 3x plus 6. We actually have to do 3, factor it out, x plus 2. So if I just said, if we have the square root of x plus 2, where does it start? At negative 2. Okay, that's what you have to do with this. Okay, so this is 3 x plus 2 square root, and this is what you're supposed to graph. Okay, so it's got a shift of 2 to the left, and it's got a horizontal compression. Why isn't it a stretch? Because it's inside and it's horizontal. Horizontal always does the opposite of what you think it does. You think it's a stretch, it's horizontal compression of a factor of 3. Okay, now we're going to bring it outside, like we talked about. We could say this is the square root of 3, square root x plus 2. They're going to look the same. Okay, they're going to look exactly the same. Okay, we can even show that. So if we look, okay, so we have y is equal to square root of 3x plus 2, right? Or y equals square root of 3 times square root x plus 2. Right? You can't tell the difference between these two. Okay, not so for trig functions, but that's how this works for algebraic functions. Okay, so let me go ahead and do that. Okay, pause this for a second. All right, carrots. All right, so yeah, so that's what phase shifts are going to look like in trig. Is that they're different from algebra, where it didn't really matter, but with trig, it's actually going to matter. It's going to move the whole graph left to right. Okay, so just to give you an idea, y is equal to, say, sine of x minus a. Put a slider in there for a. We'll turn those off. Okay, as I move it, see, it just moves it back and forth. All right, I'll do a, you can see this, maybe you can't. All right, so again, might be easier to see it. Why is it doing that? It's because I didn't put a 2 here. So it's changing it. Okay, these are kind of cool, actually. Sine of 3x minus 3a. We built a whole bunch of stuff just on adding more and more and more frequencies here. Okay, but if I don't put the little 2 here, then it's a little bit offset because we're not doing the same a as we're going forward. Okay, it's different. Well, the a is the same, but the effect is different because we don't have the multiplier here. Okay, so in this case, all of it is like 1. And this takes care of that. All right, let's go back to our problem rather than come up with new problems to solve. All right. So what we have here, right, is we have a phase shift. This one's kind of nice, right? The phase shift is just shifted to the, when it was a plus, it was shifted to the left, didn't it? And it's shifting by pi over 5. Okay. The phase shift is 1. Shift to the left. Oh, the phase shift is positive. No, the phase shift is pi over 5. And the graph is shifted to the left because if it's positive, we go negative. If this looks negative, we go positive. Okay, it's the opposite of what you think. Negative. All right. All right. Now this one, phase shift is, remember we had to factor this out. Okay, so we have to be a little bit careful here. So our phase shift is 3x plus pi over 5. What we're looking for is 3x plus pi over 15, right? Because we have to divide that 3 out. So that's what's going to happen here. Okay. Now the reason why it's a negative, right? Really what you're looking for is x go minus a negative pi over 15. Okay, so that negative kind of belongs to the phase shift formula. And then we have to adjust the sign, SIGN sign, on this bit in order to tell it whether or not it's going to the left or the right. So now it doesn't look opposite anymore because we have, okay, we have 3x plus 15, or x plus pi over 15, okay. And we know that it's going to the left, okay. But if we write it this way, maybe it makes more sense that it goes to the left now. Okay, but this negative has to be there. Just like when we did circles, right? It was x minus h squared plus y minus k squared equals r squared. Okay, so that's where that's coming from. All right. So we have phase shift is negative 3 over 15, 3 pi over 15, right? And it's shifted to the left. All right. Oh, it's not 3 pi over 15, is it? It's just pi over 15. What am I doing? Right. Double check to make sure I got the right problem. I do. Okay. Aha. 3 pi x over minus, so at least this one's minus. It's going to go to the right, so we don't have to worry about a sign shift. But what we're going to do is we have 3 pi x minus pi over 5. We gotta pull this out. So this is going to be 3 pi, because that's going to affect the period. And this is x minus pi over 3 pi times 5. That's not going to like that. So we're going to have 3 pi over x minus 1/15. Okay. So our period, right, would be 2 pi over b. Our period is going to be 2 pi over 3 pi. Okay, so that's 2/3. This is what's going on here. Okay, so let's go ahead and take a look at that. All right. So phase shift is negative. Oh no, it's just it's not negative. It's 1 over 15, and the graph is shifted to the right. Okay. All right, that should be fine. All right. I'm sorry, phase shifts are a little confusing. I am. Okay. So for the following questions, for y is equal to 4 sine pi x plus, or sorry, 4 sine x plus pi. express your answers as simplified fractions, and put in ordered pairs. So remember that for me, ordered pairs. Okay, graph the function and its key points on the interval from negative pi to positive pi. Identify the amplitude, period, and phase shift. Okay. So what are we working on here? We have 4 sine x plus pi. We have 4 sine x plus pi. Okay. Our amplitude, right, that's going to be 4, right, because that's the number in front. That's the absolute value. Okay. Period. We don't have anything over here, right? So this is 2 pi. But our phase shift, right, that's a negative pi. This is positive. So we're going off to the left here by pi points. Okay. So we're shifting by pi to the left. All right. So if I just graph my vanilla sine, right? Here's my vanilla sine. We have 0, pi over 2, pi, 3 pi over 2, and now 2 pi. Okay. What do we have with this? We have x plus pi is supposed to actually, we really like it to be 0, okay, because we know our starting place is going to be 0. So to solve this for x, we get x is equal to negative pi. Okay. We have x plus pi is equal to pi over 2. Okay. We're going to have x is equal to negative pi over 2. Okay. X plus pi equals pi. We have x is equal to 0. We have x plus pi is equal to 3/2 pi. If I take 3/2 minus 1, right, we have pi over 2. And we have x plus 2 pi is equal to, sorry, x plus pi. That doesn't change. Okay, that doesn't change. X plus pi equals 2 pi. Subtract pi from each side, we get x equals pi. Notice when they asked us to graph it, they asked us to graph it between negative pi and positive pi. This is why. It's because they knew they had a phase shift there. Okay. So let's go ahead and start. So we have an amplitude of 4. Okay. We have a period of 2 pi, because we're not changing anything about that. Okay, our phase shift is, I'm going to say negative pi, okay, because we're going to the left. All right, and then we have to graph this thing. But fortunately, like, if I can graph pi, then I can graph it like in my new coordinates, my new points. Okay, so what I want for x to be 0, it's actually going to be over here at x equals negative pi. Okay, so remember it crawls up. So we're going to go up to 4, because that's our amplitude. Okay, back down to 0 at pi. That's where we have this, right? So when x equals 0, we want x to be pi. We're really at x equals 0. Okay. And then at pi over 2. Okay, so and then we're back to the pi. Okay, and we'll just graph that. And all we've done is we shifted the graph, okay, pi units to the left. Okay, that's all we've done. Okay. Can I check? Where am I checking? There we go. There we go. Okay. So we're good. We like it. Okay, and there we are. All right. They're going to be mean. Okay. This is about as complicated as I would ever put on a quiz, though. Okay. So if you're worried like everything's going to go nuts, like not everything, this is hard enough. Okay. So I hope they don't get too much harder than this, but this is the maximum difficulty I would want to put on a quiz. Okay. So express your answers in simplified fractions, do ordered pairs. So what's our amplitude, period, and phase shift? All right. So what we're going to do, okay, we have y is equal to cosine 3x minus 4. Minus 4, minus pi over 4, minus pi over 4. Okay. So the first thing we're going to do is we're going to change this to the format so that we can deal with this phase shift. So we're going to say this is 3x minus pi over 12, right? Because 3 times pi over 12 is really pi over 4. Okay. So if we pull this out, right, we got to divide by 3 here. That's what we're doing. Okay, if I put it back in, am I going to get the same thing? Yes. Do we want to check? Okay, sure, you could check, but you better get the same thing if you reverse your step. Okay, so double check that. If you're worried about this at all, double check it. Okay, what's our amplitude? Amplitude's 1, they didn't put anything on the outside. What's the period? All right, we are going to go ahead and try something a little different to get the period. So here's our x, here's our y. Actually, I'm not going to do that just yet. Usually with a cosine, these are the points you'd really like to see, right? If I just had the graph of vanilla cosine, this would be it. So what we're going to do is we're going to say, and it doesn't matter if you change it or not. We can say 3x minus pi over 4 is equal to 0. Okay. So we have 3x equals pi over 4. 3x, or just x rather. X equals pi over 12. Okay. So this is my start. Okay, that's my start. Now, remember how cosine starts. It starts up here, comes down. So this 0 place, like where x could be pi over 2, right? We would expect to get a 0 here. But we're going to say, well, what does this middle thing have to be to get this answer? 3x minus pi over 4 equals pi over 2. Okay, so we're going to say this is 3x is equal to, I have a half plus a quarter. Okay, isn't that 3/4? Okay, that's 3/4. So x is equal to, right, 3 divided by 3, so we have pi over 4. Or 3 pi over 12. Why did you write that way? You'll see. Okay, we have 3x minus pi over 4 equals pi. Okay, so we have 3x equals, right, what's a dollar plus a quarter? 5/4. Okay, so we get x is equal to 5 pi over 12. Okay, so we go from 1 pi over 12 to 3 pi over 12 to 5 pi over 12. Do you sense a pattern? I bet you do. Okay, that's why I wrote it that way. 3x minus pi over 4. If you don't, that's okay. We got you. Okay, so this is going to be 3x is equal to a $0.50, right, plus 25 cents. Okay, so we can go ahead and do something like this, get common denominators. So we have 6 pi over 4 here. That's equal to 7 pi over 4. So we have 3x equals 7 pi over 4, right? So if we have 6/4, right, that's $1.50, plus 1/4, and we get 7/4. Okay, and then solving for x, we get x equals, and this is, what do we have? We have 7 pi over 12. And again, I'll bet you knew that. I'll bet you knew 1, 3, 5, 7. Guess the next one, right? So we have 3x minus pi over 4 is equal to 2 pi. We have 3x is equal to 2 pi, so $2, 8/4, plus 1/4. So we get 3x is equal to 8/4 plus 1/4, 9/4. And then we'll divide by 3 here, so we get x equals 9 pi over 12. Okay, what's the period? it's the beginning and the ending, right? So it's 9 pi over 12 minus 1 pi over 12. So this is 8 pi over 12. Okay, and we can cast out a 4. So we're going to get 2 pi over 3. Okay, so that is my period. And if you use the formula of the 2 pi over b, guess what you got? You got 2 pi over 3. Okay. I like this way more because I will forget this formula. Like just 3 months after you walk out of this class, 2 months after you walk out of this class, you will not remember this. But if you know, like, well, I know how to find the beginning and the end, and I know how to subtract, we don't really need to remember this formula if we don't want to. And if your job depends on it, or you're in another class where you're doing a bunch of trig, you probably want to remember that formula. But if I'd rather you forget this formula than you forget a logarithm formula. Okay. So there we go. All right, what else do they want to know? They want to know period. They want to know phase shift. So remember, we had to put the phase shift in this particular form. So our phase shift is pi over 12. Where do we start? Like if I go back up to here and I said, where do we start? We start pi over 12. Where would we have liked to start? We would have liked to start at 0. So I know that there's a shift of pi over 12 to the original function. Okay. So when we have our phase shift, we already have it from, not here. Okay. We already have it from the, maybe May. Okay. We already have it from doing our little anchor point thing. All right. So amplitude, what was the amplitude? Amplitude is 1. Okay. Our period is, right, what did we say it was? It was 2 pi over 3. What did we calculate it was? It was 2 pi over 3. All right, so period is 2/3 pi. All right. Period is 9/12 not 3/4? Or no, 9/12 is not 2/3. Cast out of 3. Oh, I'll bet I did. It should be 2 pi over 3. That's not what I wrote down. It did. Okay, let's cast out. Oh, I'll bet it is. I'll bet it is 3/4. No, it isn't. This is cast out of 3, so this is 3 times 3, 3 times 4. Okay, I like 3/4. How did I get the wrong B then? Oh, 9 minus 1. What am I doing? It should be. Cast out 4. No, get rid of this. I'm sorry. This is garbage. This is the right one because we want the distance. We want 9 minus 1 over 12 times pi. So that's 8 pi over 12. And then we're going to cast out a 4. That's 4 times 2. That's 4 times 3. Cancel that. We get 2/3. There's no pi here up in the front. I wonder if they want it here. Oh, you people. Not you. The Connect people. Like 2/3 pi versus 2 pi over 3. Those are the same thing. How dare you? Okay, phase shift is pi over 12. And then I graph the function. Hey, you know what points we already have? We already have some points that we know about, right? So we're going to do pi over 12, 3 pi over 12, or pi over 4, 5 pi over 12, 7 pi over 12, or 9 pi over 12, which is, again, 3/4 pi. Okay, did they give us enough? Look at that, they are so nice to us. Okay, this is a cosine, right? So up here, okay, maybe not so nice. Okay, what was our second one? Our second one was pi over 4. Here, okay. What was our third point? Our third point is 5 pi over 12. Okay, then we had 7 pi over 12. Okay, and then we had 3/4 pi because we calculated that one before. Right, double check to make sure my period is correct. It is, we're good. Go ahead and graph our function. Okay, they're going to do a little bit more, that's fine. Check our answer, call it good. Okay, and say that's it. That's a pretty involved problem though. Okay, but that's the kind of thing I would ask you to do. All right, that's the hardest thing I would ask you to do, because what do we have? We have so many elements, right? We have a sine of bx plus c plus d, amplitude, vertical shift, right? Period shift and phase shift. Those are all the things I can change. Okay, I'll pick a maximum of 3. Okay, but sometimes I'll only pick 2 because of that. Okay, because those are a little involved. All right, and I understand that. Okay, 16 here. Write a function a sine bx minus c for the given graph. All right. All right. So you know that sine starts, right? Where does sine start? It starts like that. Okay, so anytime where I get like this point here where I can kind of identify the start of a sine wave, that's going to be where I want to look. So that right here, that's pi over 4. Okay, so I'm kind of thinking my phase shift here is pi over 4. Okay, it looks like my amplitude, right? It goes up and down by 1/5. So my amplitude is equal to 1/5. Okay, and my period's the length of one sine wave. Okay, so here's my start, and where does it end at 0? So we have 9 pi over 4 minus pi over 4. So 9 pi over 4 minus 1 pi over 4. 9 minus 1 is 8 pi over 4, which is a fancy way to say 2 pi. That's a standard period, so I don't have to worry about it. Okay, the coefficient is a 1. So it looks like we have a 1/5 sine. We have b is equal to 1 x minus, because we're moving off to the right, of pi over 4. Do you have to write the 1? No, I just wanted to fill it in and make sure I covered everything. Okay, so this is going to be, what do we have here? We have 1 over 5 sine. We have x minus, and then pi over 4. All right, we'll check. All right. So again, good problem. Okay, and if I'm going to screw around with like a period and a phase shift, I generally will not put both of them in the same problem because that's a lot to deal with. All right, so I understand that could be rough. Okay. Speaking of which, okay. So answer the following questions. All right. Identify the amplitude, period, phase shift, and vertical shift. Good grief. Graph the function, identify key points on this. What do you want to bet? That's it's one phase, it's one period rather. What did we start off with here? Okay, so this is a 5 sine 4x minus pi. So this is 5 sine 4x minus pi. Okay, minus 2. Okay, what's your amplitude? 5. Okay, what's our vertical shift? It's the one that's outside the function, minus 2 down. Okay, what is our period? What is our phase shift? Okay, so I'm going to do it the same way I did before. I know it's a little bit longer, but I don't require myself to know any formulas. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And again, it's not that you don't have them memorized right now, but what I am worried about is like when you're in the middle of Calc 2 and they're like, hey, figure this out. I'm like, I don't remember. Do I have a chance to look it up? Like, nope, it's on an exam. No, looking it up. Like, no, that's not good. So this is 4x minus pi equals 0. So this is 4x equals pi, x equals pi over 4. There's my phase shift. Because where would you like to start? I'd like to start at 0. Where did I start? Pi over 4. Okay, let's look at the last one. Okay, we have 4x minus pi is equal to 2 pi. We have 4x is equal to 3 pi because we add pi to both sides. So we're going to get x is equal to 3/4 pi. What's my period? My period is 3/4 pi minus 1/4 pi. Where did I start? Pi over 4. Where did I get done? 3 pi over 4. So that's going to be 2 pi over 4. Because you know what? Like on one of my quizzes, I'm not going to tell you to draw it between these 2 points because it's too easy for you to figure it out. Right? They told us between pi over 4 and 3 pi over 4. What if they lied? Okay. What if I said between 0 and 3 pi over 4? Now where are you? Okay. So we have our beginning and our end. Okay. Do you want to do the middle one? Let's do the middle one. This is 4x minus pi equals pi. So we have 4x equals 2 pi, where x is equal to pi over 2. Okay. Let's do the 2/4 points. So 4x minus pi is equal to pi over 2. So we have 4x is equal to, I have $1.50. We're adding a pi to each side. So we have $1.50. That's 3/2 dollars. So x is equal to 3 pi over 8. And then here we have 4x minus pi is equal to 3 pi over 2. You have $1.50. We're going to add $1. Okay. So we're going to get 4x is equal to $1.50 plus $1, right? That's $5.50, $2.50. Okay, so this is 5 pi over 2. Okay, divide both sides. We have x is equal to 5 pi over 8. Okay, let's change this a little bit. This is 2 pi over 8, 3 pi over 8. What's a good way to write 4 in 8, or 2, or I'm sorry, 1/2 in 8. That's 4 pi over 8, 5 pi over 8. And then this is going to be times 2 times 2, right? 2 and 2. 6 pi over 8. All right. So you didn't have to go through all the arithmetic or all the algebra. You could have done 1, 2, maybe 3, and just filled in the other ones. Okay. So amplitude. What is our amplitude? Our amplitude is 5. Okay. The period. What is our period? Our period was, what did we say here? We said it was 2 or pi over 2, right? It's pi over 2. Because they want it simplified. Okay, check. Phase shift was pi over 4. The first one we did. Pi over 4. Okay. Vertical shift is -2. Down 2. All right. And now we have to deal with this. Okay. The first thing I really want to do is when I go to graph this thing, because I don't want to think too hard about it. So I'm going to go down 1, 2. Okay. And that's going to be my new sort of baseline that I'm going to go above and below. Okay. We're going to go from pi over 4 to 3 pi over 4. That's my beginning and my end. halfway between, right? What's halfway between is pi over 2. This is pi over 2, okay? And then we're going to label in 3 pi over 8 and 5 pi over 8. So here's my 3 pi over 8 and my 5 pi over 8. Is this a sine or a cosine? What did they say? Do one at a time. Okay, and it's a positive 5? It's positive. All right. It's going down here. Okay. So sine starts at 0, sine ends at 0. All right. Now here we went up to 1. Okay, so we've got to add, right? 5. Okay. So it's going to be 1, 2, 3, 4, 5. Okay, so at pi, 3 pi over 8, actually, we had to shift it, right? So we're here. Okay, forget that. Well, we are at pi over 8, we are at our maximum. So way up here. Back down at pi over 2, we're back down to 0. And 5 pi over 8, we are at minus 2, minus another 5. 1, 2, 3, 4, 5, 6, 7. Okay, so we're down here. Okay, not drawn to scale. All right. And actually, this shouldn't be up here at 5. It should be up here at 3. All right, so we're going to go all the way up. So, okay, this was all the way back down here. Okay, all the way down to minus 7, and then back up to minus 2. Okay, it'll look prettier on the graph. Okay, but I know what I want it to look like. I know what points I need. Okie dokie. So down here, right? Where are we starting? We are starting at 2 pi over 8 or pi over 4. And we are going to be down here at -2. So we are pi over 4, -2. Then we get to pi over 2. And then we get to 3/4 pi, right? That was our beginning, our end. You guys are going to have a slightly easier time than all of us. Okay, so let's see. We're going to move up 1, 2, 3, 4, 5 up to 3. Okay, back down to 0, and then we're going to go here. We're going to go 1, 2, 3, 4, 5. Okay, and hope for the best that this is my baseline. This is up, down. There we go. Let's push this in here. All right, and fingers crossed. Hey, and it liked it. All right, that's the kind of graph that I want you to be able to build. Okay, is to be able to do this, plot these points, tell me what the the min, max, and intercepts are, or baseline points. Okay, so that's what you have to do. This was a harder problem than I think I would ask you. No, it isn't, because this was a 1. Okay, so if I asked you to graph something like this, that would be fair. Okay. Okay, that would work out. Okay, so we'll call it there. We'll say that's good, and be done with this, and we'll go to a different section next time. All right.